Okay, so this is the part of the chapter where we really have to learn how to write formulas and name ionic compounds. This is crucial for your success in chemistry and for your success in the rest of the chapters in this book. So you probably should know this already from an intro chem class, but in all of my years of teaching, and I've been teaching many years, I've had so many students not know this at all. So here are the rules. Make sure you know how to do this. Okay, we're going to first start off with creating binary ionic compounds. What are binary ionic compounds? Those are ionic compounds that are made up of a metal and a non-metal, just two different elements. One element is a metal, the other element is a non-metal. Okay, in order to figure out how many of this metal hook up with how many of this non-metal, you need to know the charges. And then once you know the charges, your final answer has to have 0 charge. Okay, how do we know the charges of the metals? Here are the rules. There are a bunch of metals that are considered fixed charge metals. What are the fixed charge metals? Group 1A. So all these group 1A. So, not hydrogen. Hydrogen is a non-metal. So even though it's in group 1A, because if it's a 1 electron, we're just going to throw it back over here with the helium as a non-metal. So starting from lithium, sodium, potassium, rubidium, cesium, all of group 1A, what do they have? They have a charge of +1. So anytime you have a sodium ion, it'll be +1. A potassium ion, +1. Cesium ion, +1. And you don't show the 1. Okay. Group 2A, they're always +2. So what are group 2A? These are the alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium, all those +2. So calcium, usually we put a number and then the plus right after it. So calcium +2. Let me erase this. It's looking really crowded. Kind of wish I had a bigger whiteboard, but this will have to do. Calcium, always +2. Magnesium, +2. Barium, +2. Notice I put the 2 and then I put the plus after it. So group 1A, always +1. Group 2A, always +2. Now we move over to group 3A. These are, the representative elements. All right, we're not dealing with the transition ones. We're just dealing with the main group elements. So group 1A, group 2A. In group 3A, we're just focusing on aluminum and gallium. Aluminum and gallium are fixed and they are +3. So aluminum is always 3+, gallium is always 3+. Okay? Then the other ones that are also fixed charge on your periodic table, zinc and cadmium are always +2, and silver is +1. So over here, zinc, cadmium +2, silver +1. Those are the fixed charge metals. All other metals, so everything else that's a metal, everything else, those are called variable charge. What do I mean by variable charge? That means their charge varies. Like sometimes an iron would be +2, sometimes it's +3. Sometimes a copper is +1, sometimes it's +2. Sometimes a lead is +2, sometimes it's +4. Well, how are you supposed to know? You can figure out the charge from the context of the compound they're in, and I'm going to show you how to do that in a little bit. And when you're naming a compound, and this is super important, when you're naming a compound and that compound has a variable charge metal in it, you must use a Roman numeral to tell me what the charge is. What do I mean by that? Well, let's say you want to create a compound that has a lead in it, and you want that lead to have a +4 charge. And then you want to create another compound that has a lead in it, but you want this compound to have a +2 charge. How do you differentiate? You can't call the compound, let's say, lead oxide. You got to tell me, which lead do you want me to use? So with this one, it would be lead and then open parentheses, Roman numeral 4, close parentheses. And then this one would be lead, open parentheses, Roman numeral 2, close parentheses. For those of you who don't know your Roman numerals or never learned them in intro chemistry, let me show you. This is Roman numeral 1. This is Roman numeral 2, Roman numeral 3, Roman numeral 4, Roman numeral 5. And then I'll go up to Roman numeral 6. Okay, Roman numeral 6. Now, if you look at the periodic table, it's got Roman numerals right there on the top here. So the groups have the 1 through 18 systematic numbers, and then they also have the Roman numerals 1A, 2A, all the way over to 8A. Okay, so know your Roman numerals. All right, so what about the nonmetals? What's the charge of the nonmetals? Well, the charge of the nonmetals, the halogens are all -1. So group 7A, or the halogens, and again, hopefully you remember what those guys are. The halogens are fluorine, chlorine, bromine, iodine. Those are the halogens, okay? The halogens have a charge when they gain electrons. They like to gain 1 electron so that they can fulfill the octet rule and look like a noble gas. And they're all going to have a -1 charge. So fluorine will have a -1. Chlorine will have a -1. Bromine will have a -1. But when they gain that electron, they change the name. So it's not called fluorine anymore. Now it's called fluoride. This is a fluoride ion, and this is a chloride ion. Notice the metals don't change their names, but the nonmetals do. So when a metal becomes an ion, a cation, it doesn't change its name. It's still an iron 3 ion or a calcium ion. These guys, the minute a nonmetal gains an electron, changes its name. Fluoride ion, chloride ion, bromide ion, iodide ion. See how we've changed the names here? Can you see this okay? Yeah. All right. Same thing with the other nonmetals. So let's go to group 6A, oxygen and sulfur and selenium. So group 7A, they become -1. Group 6A, oxygen and sulfur and selenium, they become -2. So the oxygen picks up 2 electrons, and you got to change its name. It's now oxide ion. And the sulfur picks up 2 electrons. It is now sulfide ion. And then the selenium picks up 2 electrons, and it becomes selenide. You get the idea here? Okay. And then we'll go to group 5A, nitrogen, phosphorus, and arsenic. All right, so the nitrogen, remember, group 7A picks up 1 electron. Group 6A picks up 2 electrons. Group 5A, those 3 nonmetals, they pick up 3 electrons. So the nitrogen becomes nitride. Not nitrite or nitrate, always these monoatomic, these are all monoatomic ions, not polyatomic. The polyatomics are going to be the nitrates and sulfates and nitrites, and we'll get into all of that later. But the monoatomic ions always end in the nonmetals, the anions always end with IDE. Nitride. Phosphorus also picks up 3 electrons, becomes phosphide. Arsenic picks up 3 electrons and becomes arsenide. Okay? And then you'll ask me, well, what about group 4A? Carbon and silicon, they tend not to gain or lose electrons. They tend to like to form covalent bonds, and so we'll deal with them with our binary covalent molecular compounds, okay? So now that you know the charges of the metals and you know the charges of the non-metals, let's create some ionic compounds. All right, so I'll put a few examples on the board. We'll make, let's see here. All right, so I'm going to put some names of things on the board, and then I'm actually going to show you, I'll give you a whole bunch of things to play with. All right, let's say I wanted the formula of magnesium nitride. Okay, so I know that magnesium is a group 2A metal, and magnesium is plus 2, right? We just went through those rules. And the nitride is N3 minus, all right? You can't put one magnesium with one nitrogen. You can't do that to form a proper ionic compound. Why? Because, remember, we said that in order to create a proper ionic compound, there has to be a net charge of 0. And if you put these two guys together, you're going to have a net charge of -1. So what has to happen in order for these two to come together correctly to form a correct ionic compound? The charges have to cancel out. Now later on in, I think it's chapter 9, we talk about the transfer of electrons and how all of this is done. But right now, let's do it really quick and dirty, an easy way of doing it, like I call this the no-brainer technique. Crisscross the numbers. What do I mean by that? Put this 2 down here and this 3 over here and get rid of the charges. So if you do this, Mg3, N2, that is the correct formula for magnesium nitride. So what this is saying is that you need 3 magnesiums, 3 times 2 is 6 plus, and you need 2 nitrogens, 2 times 3 is 6 minus. 6 minus and 6 plus, they cancel each other out. You're all done. Okay? So this crisscrossing the charges works beautifully. Let's say I have something like this. Lead, Roman numeral 4, sulfide. Why do I put a Roman numeral? Because, like I told you guys, anytime you have a variable charged metal, you have to tell me which one you want, which charge you want. You can't just write lead sulfide. So because it could be 4 or it could be 2. So I want lead 4 sulfide. All right, so I write this down, Pb 4 plus. That's what the 4 is. It's telling me that the charge on the lead is 4 plus. And the sulfide, I know that sulfur, when it becomes an anion, picks up 2 electrons, so it's 2 minus. Okay, so if we use the technique of crisscrossing, this is going to go down here and this is going to go down here. So it becomes Pb2S4. But here's the thing, you got to do something now. Once you get your final formula, you've got to reduce it down completely. So the lowest ratio. And if these guys can both be divided by 2, you got to divide them both by 2. So your final answer is going to be PbS2. This is the formula for lead 4 sulfide. Okay, good. We'll do more practice in the next video.